This Headless Professor video is about data entry in an Excel spreadsheet. Each row is going to represent a single case, person, subject, or participant. I'm going to use these four terms synonymously. Each column is going to represent a different variable, regardless of how that variable is measured. Each individual cell, the intersection of a row and column, will be a value which represents that row's subject and how that particular subject scored for that particular column's variable. I'm going to suggest that you enter all values as numbers rather than words representing levels or categories. This is going to be easiest when we're dealing with data in interval or ratio scales. You just enter the numbers. When you're dealing with ordinal scales, I'm asking you to convert ranks or levels into numerical scores. Let's take the example of these kinds of ranks. Suppose you have 3 salespeople in the department. Now, last month, Jones sold the most, Johnson was next, and Smith sold the least. So Jones came in first, Johnson second, Smith third. But when we convert this to points that we're going to enter in our Excel spreadsheet, we're going to do it like this. We're going to give 1 point for Smith because he came in last. Johnson was in the middle, so Johnson will get a 2. And Jones came in first, so we're going to give him the most points because he really sold the most units. Therefore, Jones will get a 3. In dealing with ordinal scales, sometimes we have levels, and here's how we're going to enter points for these levels. Let's suppose we have a measure of performance like excellent, good, fair, or poor. 4 different levels in our ordinal scale. We would enter 1 point for poor, 2 for fair, 3 for good, or 4 for excellent. Here we have a Likert scale. We give the subject a certain statement, and we see to what extent the subject agrees with the statement. Strongly agree, mostly agree, don't know, mostly disagree, or strongly disagree. We'll give 1 point for strongly disagree, 2 for mostly disagree, 3 points for don't know, 4 for mostly agree, and 5 for strongly agree. Here we have an ordinal scale measuring the frequency that a subject does something. Always, usually, occasionally, rarely, or never. And once again, the more frequent the variable, the more points we'll give. 1 point for never, 2 for rarely, 3 for occasionally, 4 for usually, 5 for always. When dealing with a binary nominal scale, we essentially divide our subject into categories. Yes or no, male or female, experimental or control, pass or fail, and we'll define the variable by one of these 2 conditions. So if we define our first variable as yes, we'll give 1 point for yes. If we define the variable of gender as being male, we'll give 1 point for that. If we define grouping as experimental, then that gets 1 point. And passing the test would get 1 point. Now, if somebody scored the opposite on these binary nominal scales, if someone answered no, that'd be 0 points. If someone was not a male, in other words, was a female, that would be 0 points. If someone was not in the experimental group but in the control group, that would be 0 points. And if somebody failed the test as opposed to passing it, that would be 0 points. Here's an example of what an Excel spreadsheet might look like. In the upper left-hand corner, we have cell 1A, row 1 and column A. Notice I'm going to leave that blank. I'm also going to reserve row 1 for the names of our variables, like being male, a performance rating, and the subject's age. I'm going to leave column A empty. I'm going to use it to write some kind of identifier for each of our individual subjects. Here we have their names. If we want to preserve anonymity, we just might use something like case numbers. One good thing about looking at the Excel spreadsheet, which is lined up like this, immediately we know what the sample size is. We just look at the number of rows taken and subtract 1, because remember, we're using the top row for labeling our variables. We can then create additional rows that represent different descriptive or inferential statistics. For example, we can have a row that indicates the mean of each variable. Now what we see under the male column represents the mean of those numbers. But remember, those particular numbers were merely a code for yes, the subject was a male, in which case we entered a 1, or 0, the subject was not a male but a female, in which case we used the 0. So when we have a mean of 0.5, what that really indicates is that 50% of our sample was male. We then look at rating, and we see the mean for that particular variable, and we also see the mean age. We can create additional rows for median, or mode, or standard deviation, or correlation with another variable. Hope you enjoyed this Headless Professor video and found it a helpful explanation on Excel data entry.
Create your very own video podcast from PowerPoint. Log on to authorstream.com. It's absolutely free.